thinking that I had stopped this series because there's a lot of gap. Unfortunately, I was not well and had to take rest. And also, there was this academic load which we have to do as academicians as we change over from kind of online to offline. But this online mode of instruction will continue. This is something very close to my heart. This program that I've started, this calculus for the enthusiast. Finally, I'll make it a book. My rather first attempt at a kind of a semi-popular writing in mathematics. So today I come to discuss with you the notion of a limit. So when I say that given a fixed real number a, when I say that x approaches the variable x, some is approaching that value a, so you know what does it mean. Actually, you have the real line which is a straight line, like real number line, and then put a number a, say x is equal to 0, and I say a equal to 0. Now I am approaching 0. I can come from my right side, and I can also come from my left side. So there were 2 degrees of freedom. There were 2 ways to approach 0. So what essentially it means is that when I say x is approaching a, it means that I can always find an x very close to a. You give me a distance, say find an x at a distance of 0.00001 centimeters for millimeters, whatever, from a. The distance between x and a is of this amount, or I can obviously find a x such that the distance between x and a would be less than the amount you have certified or you have fixed. So it means that given any epsilon greater than 0, there will always exist an x such that x would not be equal to a, and the distance between x and a would be strictly less than epsilon. You might be telling me, oh, you are trying to pull me to the epsilon-delta limit business. Yeah, I'm somewhere trying to pull you there because that's a very natural language. It talks about how far one thing is from the other. It's just calculating some distances. Now, when I was in the 11th standard, we had not started studying calculus, and possibly I was not among the person who were very eager and had self-studied things. My passion more was on geometry than going into these kind of things. But when we started talking about physics, there was this teacher who came in and he said, okay, we have to talk about velocity, and you have to differentiate the distance function and all this kind. He defined velocity as delta xt by delta t. Xt is the distance, so delta x by delta t, limit delta t tending to 0, and we were very awestruck as to what's going on. Then one of my friends asked a question, sir, we are from the 11th standard, we don't know all this derivative or what you're telling ddt of x, and we have no idea about anything about the limit. He said, oh, you don't have any idea about limits? Good. Just remember one thing. Limit means coming, but still not coming. When I look back at what happened, we had a hearty laugh, but I still have a hearty laugh, and I think that he is not very, very off the track. Here, if you look at this definition, what it means is that x is very near a, but it is not exactly equal to a. That's what it means by a variable x approaching a. So it's coming very near, but still not coming. So now come to the epsilon delta game. This is something many students abhor, even when they go and read real analysis, even as math major, they abhor it. There is nothing to abhor about it. When I say that the limit of fx, the functional value of f is a function, say, from R to R, and we say the limit of fx as x tends to a is equal to L, what we mean? What is the meaning of this? Which means that when x has a value very near a, whether from the left side or from the right side, doesn't matter, the fx value must also be very near L. Whether from the left side or right side, doesn't matter, but their distances. Distance is always a positive number. So when distance between x and a is very small, the distance between fx and L must be very small. But we state it in a slightly different way. So it tells you that if you give me a distance and say, okay, if fx is a value, if I find the functional value very near L, is the x also coming from somewhere which is very near A? That is the epsilon delta meaning. It means that given epsilon greater than 0, no matter how small, I will be always able to find the delta greater than 0 such that fx minus L, this distance, would be always less than your chosen epsilon whenever x is within that delta radius, delta range of A. That is, x is in the open interval A plus delta to A minus delta. So what does it say? So don't get into the epsilon delta. अरे मुझे तो दिमाग में रखना, so many kind of, sorry, even if I speak in Hindi, मुझे दिमाग में रखना, I have to keep it in my mind that okay, I have to just mug up this thing. Don't have to mug up. It simply says that if you can find an functional value x, f of f, if a value of f, the function value is near L, then the corresponding x has to come from a x, corresponding x for which fx is near L, that x must be near A also. It cannot be that x is very far from A but fx is very near L. That cannot happen. So there is a negative statement also here, that if x is very far from A and fx is very near A, that cannot happen. If fx is very near L, then the x value is also very near L, A. So based on the choice of epsilon, you can choose your delta. Then you can say, okay, if epsilon is very small, there is another number which is very small, and within that range, all those x's, fx is lying within that epsilon range. That is, fx is lying between L plus epsilon and L minus epsilon whenever x is lying between A plus delta and A minus delta, strictly. So again, I want to assure you that this is just a talk about distances, which converted from the English language to a more sophisticated mathematical language looks like this. But it's a very useful trick. It's a useful trick that, okay, if I give you an epsilon, if you can show me that there is a range of x's very near A, for some, not exactly equal to epsilon distance, but some very small distance which depends on the choice of epsilon, for all those x's, if fx is lying in that epsilon neighborhood or epsilon range or epsilon open interval, L plus epsilon and L minus epsilon in that range, all the fx values of those x's are lying in that range, then fx has a limit L. And that has to happen for any epsilon that you choose. Here is the crux of the story. The story is, given any epsilon greater than 0, I must be able to find the corresponding delta, not just for one epsilon. It can happen for one epsilon, it may just not happen for other epsilon when you make the epsilon smaller. That can very well happen. So it's very important to note that it has to happen for every epsilon, and that is the crux of the story. Some people miss this crux, and that is where people tend to jumble up, and that is why I have repeated it so many times. And this is a story about distances when it's been converted into a mathematical language which looks very fearful, but there is nothing to fear, which says that if x is very near A, fx must be very near L. If you tell me that okay, fx must be, you give me a distance, fix up a distance for me, that find fx for which x says fx is within this range of L, that is, fx is within L plus epsilon, L minus epsilon. If I say that okay, for some x which is very far from A, one of the x's, fx is within that range, and for some near A it is there, it cannot happen. You have to find a body of x, but you cannot say it is just scattered, it can come from anywhere, it's not like that. There has to be certain x's very near A, that is lying between that fx, x should lie between A plus delta and A minus delta. For all such x's which is lying in that region, fx must lie in that region, L plus epsilon, L minus epsilon. But you cannot arbitrarily choose an x and say it can happen from there also, it can happen from, if the x can be far off also, it doesn't matter. And maybe I can only find very far off x's then it is a very difficult, then it is that then it is not the definition of the limit. The limit simply says fx would be near L only when x is near A. Limit fx equal to L means fx is near L when x is near A. That is converted into this language. That is why you always give the distance epsilon, which is the distance of fx from L. That distance is given to you. That whatever small distance you choose fx to be near L, this will happen for all those x's which are also for some x's which are near A. So when fx is near L, the corresponding x's must also be near A. That is why you give the distance of epsilon. That epsilon is the distance between fx and L first. That when fx is near L, then the corresponding x's are also near A. They cannot be arbitrarily placed anywhere. That is the idea, and that is translated into this language. Let us see how we can use the epsilon-delta game. Like show that the limit x tends to 0, x of 1 by sine x is equal to 0. Now L is here 0. L is 0 here, and so I take any epsilon greater than 0, and in this case I choose delta equal to epsilon and consider all mod x. So what does it mean by x going to 0? As I told you, it means that I can find some delta or some epsilon. In this case, I have chosen delta equal to epsilon, such that when mod x is not equal to 0, when x is not equal to 0, so mod x is strictly greater than and strictly less than epsilon. Here also, I've written here, you see x is not equal to A. Instead of just writing x is x1 as A strictly bigger than 0, I've specifically written to note that x cannot be equal to A, right? So A is taken out of the whole thing. So for all mod x of this form, observe this. Mod of x into sine 1 by x is less than equal to mod of x, absolute value of x, into mod of sine 1 by x. But modulus of sine 1 by x is less than equal to 1, because sine x values always varies between plus 1 and minus 1. And hence, mod of x is strictly less than epsilon. So mod of x into sine 1 by x is less than mod of x, and mod of x you have chosen to be less than epsilon. Delta is equal to epsilon. So x of sine 1 by x is strictly less than epsilon. So whenever mod of x is less than epsilon equal to delta, right, and x is not equal to 0, x sine x minus 0, that is modulus of x sine 1 by x, is also strictly less than epsilon. Hence, this is going to 0. So that language can be easily put to use. Now this epsilon delta game was brought into the fore by a great mathematician, a French mathematician. All those days, these people were pretty rich. They had a lot of inheritance, they used to live very nicely, and hence can do science in a much more relaxed way. Not like us, where we have to think about making our ends meet and end up doing many other things and then doing science. So he wrote a book called Cours d'Analyse. It's a French, Cours d'Analyse. And it's a French book, and where he started this epsilon delta explanation. So these are the epsilon delta games of Cauchy, Augustin Louis Cauchy. Cauchy has got huge contribution in mathematics. If you go to complex analysis, it will be only filled with Cauchy. If you go to real analysis, largely you will be filled with Cauchy. So it's the Cauchy game. So he studied in that book two limits. Limit sin x by x as x tends to 0. We should find the answer. Limit as x tends to 0, 1 plus x to the power 1 by x. Pretty not so interesting looking. Equal to something. Today our job would be to just focus on this one. Okay. Now let us do some experiments. So let us put x values to be very small in a calculator, and I try to see where does this sin x by x goes to which value it is going to. So I had a friend gifted me a long back, maybe in like 2018 or 19. Uh, Casio FX 991 ES, uh, scientific calculator, which has all kind of sign function. You can integrate, you can differentiate, but at the back of it, some kind of algorithm is running, right? When you differentiate, some central differencing is running, or finite differencing, or some kind of numerical method is going when you are integrating some Gauss. Because they have written in their booklet, some method is going, some numerical integration is going, some numerics is going. So we wanted to really maybe a sin x they are computing using the up to certain order, they are computing using the infinite series of sine, that is x minus x cubed by 3 factorial plus x5 by 5 factorial minus x7 by 7 factorial and so on. So I said, okay, let us try it out and see what happens and see where these values are going. Maybe something very odd will come, it has actually, and we'll see why. So here I am putting values you see of x, and then I am getting the values of fx, where fx is actually sin x by x. Now initially up to some 9 decimal points I am taking. Initially, okay, it's this kind of values. So you gradually see the values are increasing. See, after 3 you see 071, here you have 257. Yeah, again so the values are, maybe there is some, maybe I have to check here, maybe the value would actually increase more. I'll have to check here. So values are increasing, but then when I put very small values, you see it is simply giving fx. It is writing in fact in the screen that it is equal to pi by 180, right? I did a lot. So here you see after 0 there are 8 zeros. I started with 10 zeros, 12 zeros. It just writes pi by 180. I was observing what is pi by 180. Because if you just put the value of pi is 22 by 7 kind of thing and 3.14 by 180, then it will come to 0.017444444444. So actually it is 0.175, you assume, right? So that kind of thing, assume that kind of expression. So but every time it was writing pi by 180. Then I realized maybe because these values of fx are all approximations, because because the calculator is approximating sin x. So maybe they are writing pi by 180 to signify 1 because pi radian is 180. Maybe in that kind of thinking, then pi by 118 they have signified as if to think of it as 1, because pi radian is exactly 180 degrees. Well, you can say, okay, pi is in radians, degrees is a different thing. Why you can say? How do you say that? But I have a feeling, but I exactly cannot say that. But I have a feeling that pi by 180 is that kind of, because after that everything becomes pi by 180. It cannot be that they are all, for all these values the functional values would be. Maybe you observe the movement is very slow. Actually it moves away from 0 and actually goes towards 1. But after, as you keep on increasing the 0, the values would very very slowly change. But it cannot just be pi. They will just give you pi by 180. The calculator will just give you do that, because they possibly also know that the limit is 1. This limit is 1, and the values become so near 1, they fix it up, approximate it as 1, and which there symbolizes a kind of pi by 180. Because if you really convert pi by 180, it is 0.175. But I think they are symbolizing kind of 1. My wild guess, but I am mistaken. So let's conjecture that limit x tends to 0, sin x by x is equal to 1. Now let us go and see Cauchy's solution. So for x strictly greater than 0, some positive number, Cauchy observed this following inequality. You can actually geometrically very easily prove it, but that will be part of when I write a book on this kind of thing, then I'll put the details. Because if I tell you everything here, then the book won't sell, if I can at all write the book, right? So what happens is here, okay, I forgot to give the slash of sin x in the latex. Okay, what happens even if x is strictly less than 0, when x is negative, sin x values are negative. If you look at the sine graph, then this inequality will change. Even if you take the mod x is very very small near 0, the inequality will change because the sine graph changes. But ultimately, for any x, whenever mod x is small, when you divide, do these kind of divisions, you have sin x and then try to divide using these facts, you will actually get an inequality of this form. You will always get an inequality of this form. Just try it out at home. Sin x by tan x is strictly less than sin x by x is strictly less than sin x by sin x, which is 1. So this inequality will always come in respect of whatever your x. Cos x is strictly less than sin x by x, strictly less than 1. And here we apply what is called the famous sandwich theorem of limits. And those who want to recollect what is the sandwich theorem, let me just tell you that sandwich theorem. Oh, I had made a mistake. Please correct it. I will correct it in my next slide. Sandwich theorem tells you that if hx is less than fx and fx is less than gx, not greater than gx, this is my mistake, then for every x near a, if this is true, then if limit of hx goes to L and limit of gx as x tends to a goes to L, then limit of fx as x tends to a also goes to L. No, this is less than gx, please understand. Here cos x is strictly less than sin x by x and sin x by x is strictly less than 1. But you will take limit of x tends to 0, cos x is 1, limit of x tends to 0, 1 is 1. Okay, this is constant. So by the sandwich theorem, limit of x tends to 0, sin x by x is equal to 1. That's the Cauchy's limit. So with this we will stop here, and next lecture we will discuss the other limit, which will take us to the Euler's number e, the exponential, and there you will see the beautiful use of infinite geometric series, and also the binomial theorem. How powerful! Newton's real discovery is the binomial theorem. Its power is amazing. Whether you do calculus or you try to do any other thing, binomial theorem is the real powerful thing. So with this, and sorry for the typos here and typos there, I think I'm getting really older. So I say a goodbye to you on this Sunday. Have a nice Sunday and hope you enjoyed it. Thank you very much.